After you made your forecast, we need to talk about the forecast accuracy and control. So because forecasts are generally wrong, we need to consider allowances for forecasting errors. So that means that it's important to know an indication of the extent, the level to which the forecast is going to be off. It's going to be wrong. And we need to accept that nature of inaccuracy for forecasting. So for example, we're going to say, okay, we are going to be fine 10%. We assume that 10%, the forecast is going to be 10% wrong. That means that the actual value is going to be 10% below or 10% above the level predicted. So that's our allowances, and we accept that. Okay. Then after we made the forecast, we get the real actual data. We need to compute the accuracy of the forecast and the error of the forecast. Um, we always need to monitor those errors. How do we compute the errors? Well, that's simple. So the error is the deviation of the forecasting result, the forecasting number that you have, the amount that you forecast from that deviates from the actual value. So that's the actual value for your variable minus the forecasting amount that you have. For example, if you made a forecast for the next month's your next month's sale to be 1 million units, whatever unit is, and then your actual sale came after a month, and it's actually 1,200,000, or it's actually 900,000. So that would be the actual sale minus the forecast that you have. That's going to be error. So it can be positive, it can be negative. Okay? And then knowing that errors, then we're gonna go back to the allowances. So if the level of error is within the allowances that we gave it, we accept it. For example, if it's within the 10% allowances that we give it to, then it's fine. If it's not, if it's higher than that, if it's beyond the allowances level that we have, then we need to make a corrective action. We need to control the forecasting. Forecast error calculation. So the formula is very simple. The error for a forecast is the actual data, the actual value of the variable, minus the forecast value or the amount. So let's do this for this table that we have the forecast. So we have 5 periods here. We have the next column is the actual values. It shows by A. So the first period is 107. For the second period is 125, etc., etc. The next column, it shows our forecast for that period, whatever the variable is. Suppose it is sales, for example. So the forecast for period 1 is 110. The actual value is 107. The error would be the actual minus the forecast. So that would be 107 minus 110, which is negative 3. So the error would be here, negative 3. The error for the next period forecasting is the actual value is 125, the forecast is 121. 125 minus 121, that's 4. So the error here is 4. For the next period, period number 3, the actual is 115, the forecast is 112. 115 minus 112, that's 3. For period number 4, the actual is 118, the forecast is 120. So 118 minus 120, that's negative 2. Negative 2. For the fifth period, the actual value is 108. The forecast is 109. So the error is 108 minus 109, which is negative 1. As you see, it's very easy to compute this. Forecast accuracy metrics. As we stated earlier, any forecasting that you want to use, forecasting technique, or you want to suggest to, for example, your boss, it has to come with its accuracy level. The level of accuracy that it is has been performed in previous examples or previous use. Because we know that forecasts are generally wrong, and we need to know the level that they are to, the accuracy level, so that when we use it in the future, we know that how much off they would be, how inaccurate we have to expect them, or how accurate we have to expect them to be. So now the question comes to, what should we use as the accuracy metric? What should be the accuracy metric computed? Well, here we have a table. This is the same data that we had before. So we have 5 periods here. We have the actual data. And then the next column, the third column, we have our forecast. So I have made only one change here. For the 5th period, I changed our forecast from 1009 to 1010, just to make a point here. So that's the only change that I have made. And in the last column, I have computed the error based on this formula, which is errors is equal to actual value minus the forecast, which is the first column minus the second column for each period. Well, you might actually think, why not, when you have these errors for each period of our forecast, why not actually compute the average of these errors and consider that as the accuracy metric, right? So the average error that we have, our forecasting method have made for these periods. Well, that's actually an interesting idea. Sounds like it. So this means that what we need to do is compute the average. So accuracy is equal to the summation of error that we have divided by the number of periods here. So this means that we have to find the average of this. So that's -3 plus 4 plus 3 minus 2 minus 2. So if you actually compute this, these two is going to cancel out this one, and this is going to cancel out that. So that means that the summation of errors is actually 0. 0 divided by 5, we have 5 periods here, that would be 0. So the average error that we have here is 0. Does this mean our forecast is exactly accurate, 100% accurate? Well, apparently not, right? This is an untrue, unwise statement to make here. Because we see here that our forecasting for each period has actually been off. It has been either less or more than the actual value. For none of the periods, actually, it has been 100% correct. Okay? So it is not true. It is not a true statement or claim to say that this forecast is 100% accurate. That's what it means when we say that the method that we computed for accuracy, which is 0. So that's not true. So what should we do? So what happened here is, as you notice, we had the canceling effect here. So these two cancel each other, these three cancel each other, and these also cancel each other. So we have a problem called canceling effect. How to deal with this problem? Well, what we could do is, because we have some surpluses and we have some shortages, so we have some positive number and some negative number that they cancel each other out when you sum them up. So why not actually consider the absolute value of this? So that's one way to consider. Instead of using these values on their own, we use their absolute value. So this means that this would be 3, this would be 4, this would be 3, this would be 2, and this would be 2. That's the absolute value. Or we could actually square these values. That's another option, right? Well, based on these two ideas, the accuracy metrics that we're going to talk about the popular accuracy metrics that are used, they use the similar idea. They either use the absolute error or they use the square. Right. So let's see what they are. The first metric, the accuracy metric, is called mean absolute deviation, or MAD. This method uses the absolute value instead of the real value of the error. It uses the absolute value to avoid the canceling effect. Let's see how it works. So we have the formula here. The mean absolute deviation or mean absolute error, MAD or MAE, here we use MAD, deviation, is equal to the summation of absolute value of error. So that's actual value minus the forecast. This is error, as you see here. This is error. So MAD is the summation of the absolute error divided by n. N here is the number of periods, and T is the index of the period that the forecast or the error is related to. So what MAD does here actually, it weights the errors all evenly across the periods that we have made the forecast for. So this is a straightforward formula and also idea, right? Finding the average absolute value of the errors that we have made. Let's see how MAD, the mean absolute deviation, works. So here we have the same, this is the same table. I have just added the last column, as you see here, to compute the MAD. So we have on the second column, we have the actual values for the 5 period that we have. The next column, we have the forecasting that we have made for these periods. And on the third column, we have their errors. So to compute the MAD using this formula, we need to find the absolute error. So this means that we have to absolute these values. So for the first period here, the error is -3. This means that the absolute error would be 3. For the second period, it would be 4. For the third period would be 3. For the fourth period would be 2. For the fifth period would be 1. So what we need to do now is we find the summation. So we're going to sum these up. So that would be 3 plus 4 plus 3 plus 2 plus 1, which is a total of 13. So I'm going to put 13 here. And n is here 5. So MAD would be 13 divided by 5 according to this formula. 13 divided by 5, which is equal to 2.6. So I'm gonna put it here, 2.6. So that's our MAD. MAD is 2.6. There is another metrics, forecast accuracy metrics. It's called mean squared error, or MSE. So in these metrics, instead of using the absolute error, it actually used the square of the error. As you can see in the formula here, it actually finds the error here, then squares it, and that would actually help us to avoid the canceling effect. So this is just the square of error. So MSE finds the average of the squared errors, and here we actually divide it by n minus 1. We're not going to talk, you don't have to know why it's n minus 1. Some actually books use n, but here we use n minus 1 to be consistent with the book. So MSE, as you see in this formula, is the summation of a squared error divided by n minus 1. Let's see an example. So we're going to use the same example that we used for MAD to compute MSE. All right, so here's the table. I have added another column here. That's the last column is error squared that we're going to use for this formula, the MSE formula, to compute the mean squared error as a metric. So let's go ahead and do that. For the first period, The error is -3. So the squared of this would be 9. This is 9. For second period, the error is 4. So the square would be 16. For the third period, the error is 3. So again, it would be 9, the square of that. For the fourth period, the error is -2. So the square would be 4. For the fifth period, the error is -1. So the square would be 1. Now we sum these values, the square of error up. The summation of these would be 39. 39. And we have to use n minus 1. We have to divide it by n minus 1 as in the formula. So that would be, the MSE would be 39 divided by 5 minus 1, 4. 39 divided by 4, which is equal to 9.75. So that's going to be our MSE, 9.75. The MSE is 9.75. All right, so we computed MAD. MAD is 2.6. MSE is 9.75. When you have multiple forecasting techniques, you have applied them. You can use any of these metrics, MAD or MSE, to compare each value from each forecast to decide which one is better, more accurate. So the lower this value, the better. There is another forecast accuracy metric. It's called mean absolute percentage error, or MAPE. MAPE, as you can see from this formula right here, it uses the absolute value of the deviation of our forecast and the actual. It divides it by the actual, so it finds the percentage, and then divides the whole thing by the number of periods. So as you can see from the shorter formula, the MAPE is the summation of absolute error divided by its actual multiplied by 100%. So it computes the absolute percentage error, and then it adds them up and divide them by n. So it gives us the mean or the average absolute percentage error for our forecast. Let's see an example how this actually method works. So here we have the same table. I have added the last column to compute the absolute error divided by the actual multiplied by 100% to compute the mean absolute percentage error, as you can see the formula here. Right, so let's go ahead and do it for period 1. So what we need to do is find the absolute error. So the absolute error is 3. You already have it here. Then divided by actual. Actual is 107. So that would be 3 divided by 107. And then find the percentage of it, which is 2.80%. Then write it here. So that is 2.80%. So that's the mean absolute error, mean absolute percentage error for the first period. So let's now find for this for the second period. For the second period, the absolute error is 4. The actual value is 125. So we have to find 4 divided by 125, the percentage of this, which is 3.20%. So that's 3.20%. And we're going to do this for period 3, period 4, and period 5. So I already have computed this. Let's see it. All right. At the end, we have to sum these up. So that's 11.23%. And then we're going to divide it by 5, as you can see it from this formula. So that's 11.25, 23% divided by 5, which is 2.25%. So the mean absolute percentage error for this forecast is 2.25%.